So we know how to solve x squared equals 1. X squared equals 1, you take the square root, you have two solutions. You have two real solutions. All right, we have two real solutions. Has two real solutions. X squared equals 0 we can solve. We take the square root, and plus or minus the square root of 0 is just 0, so we have one real solution. And if you have x squared equals -1, what you've learned so far is that it has no real solutions. All right, so you might have heard that it's just no solution, but it's really that it has no real solution. So it does have a solution. It's just not a real solution. Now, is every one of you going to use non-real numbers in your everyday career? No. Okay. Somebody get that, please? Thank you. So, but are there fields where it's used? Absolutely. All right. So, for example, we talked a little bit about electrical engineers use it. All right. So electrical engineers use it to help represent the traveling of currents because there are multiple components to a current. And so basically they're parallel number systems, and so they use this additional number system to represent the different currents. And both currents might be moving together, but they might have different forces involved in them. It's used in different fields of engineering and physics whenever we want to represent multiple forces acting at the same time but not combining. We'll use this imaginary system to show these parallel values traveling along each other. So it's used in specialized fields, not everyone. But you need to be open to I have to make sure that all career possibilities are open to you. And so we need to make sure we have an understanding of what this concept is. Okay? And so our imaginary numbers help us solve things like x squared equals -1. So this forms our imaginary numbers, which is the square root of all negative numbers. All right, imaginary numbers are anytime I have the square root of a negative number. It has to be a square root. It has to be a square root. And so all of these numbers are written in the form of BI, where B is a non-zero number and I is my imaginary unit. Notice I is kind of that script I. We call it script I, or it's an italicized I. You will see me write it with that kind of curve to it. And the reason is if you do physics, there's a horizontal unit of measurement that's represented with I, but it's a bold, straight-faced I. Love math. All these letters, and they like to use the same ones. So an italicized I does have different meaning than a straight, bold one. So as a result, I will write it one way. Don't stress too much about that, though. Okay, but when you see it in text, it's written with that italics for a reason. Because as you get higher in math, there are multiple other variables that come into play. All right, and so that imaginary unit represents the square root of -1. So by definition, I is the square root of -1. Ways we can write this, we usually write our coefficient in front. So notice 2i, the 2 is written in front. -5i, the -5 is written in front. If I have -1/3 I could write the -1/3 in front, or I can put I in the numerator. All right? The only time I write I in the front is if there's a radical. If there's a radical, I'll write I before the radical. That way it doesn't get confused as being underneath the radical. Yeah, and if there's a fraction with a radical, you kind of have options on how you write it. Am I going to mark you down because you didn't write it in this order? No. Okay, but you do have to have that component of BI together. Now, what if you had I squared? Well, I squared is the square root of -1 squared. And what happens when you square a square root? They cancel out. They're inverse operations. So that I squared is negative 1. I is an imaginary number. Is negative 1 imaginary? No, that's real. So I squared is a real number. So this is imaginary. That says imaginary, I promise. And then this I squared, so imaginary. I squared is real. Because the action of squaring got rid of the square root, which is what caused it to be imaginary. So squaring the imaginary unit creates a real unit. Which, it's not that out of the question for what you guys are used to. Because negative 1, you know negative 1 is a negative number. Negative 1 is absolutely a negative number. But negative 1 squared is a positive. So it changed its type of what we classify it as. It changed it from changed it from being a negative number to a positive number. So you change classifications all the time without thinking about it. But now we're adding in this complex number system that might be a little bit of a head bender, but it's still similar to that concept of when you square that negative 1. All right, so let's go ahead and go to the next page. All right, so A is worked out for you there. I'm going to do B with you and maybe some more with you. All right. So if I look at B, I have negative I, the square root of 2. Now, I'm going to break this up maybe a little more than the book has. All right, I'm going to actually, so the directions say to square, find the square of my imaginary number. So that's why they're squaring it, is because the directions tell us to. I'm going to actually do my work to the side because I'm going to do it a little bit different than the book. That negative I square root of 2, that's like negative 1 times I times the square root of 2. Are we okay with me writing it like that? Negative, I can always write as negative 1. So instead of being negative I, it's negative 1 times I. And the reason I want to write it like that is to help us see what happens to that negative. So properties of exponents let me distribute the exponent across multiplication. I can distribute the exponent across multiplication. So each of these terms gets the square. What's negative 1 squared? Positive 1. So that's positive 1. I squared. So I squared is at square root of negative 1 squared. So what's the square root of negative 1 squared? So I replace that with negative 1. And what's the square root of 2 squared? 2. So I have 1 times negative 1 times 2. Negative 2. So my solution is negative 2. Is negative 2 real or non-real? Real. It's a real number. All right. Okay, let's look at number 9. Let's take a look at number 9. I have negative 2i. What do my directions say? Okay, so I'm going to square it. So I get negative 2i squared. Audrey, what can I do with that square? What did we do on the last problem? The square, did the square just go to one value or did the square go to all the values? All of them. So it distributes to each item. So I get negative 2 squared and I squared. It distributes across multiplication. It distributes across multiplication. So negative 2 squared is, and then I squared is So 4 times negative 1 is? Is that real or non-real? Real. All right. So let's look at 10. Okay. So the first thing I'm going to do is that same direction of squaring it. Camille, what do I do with my square? What gets the square? Okay, tell me everything. List everything. Okay, so I gets it. What else? So the numerator and denominator of your fraction get it. The numerator and denominator of your fraction get it. Okay, so squares, exponents distribute across multiplication and division. All right, so every item in there is getting it. So the square root of 3 squared is? 3 squared is?
9.
I squared is? Does 3 over 9 reduce?
Yes.
What does it become? Is this real or non-real? All right. So let's look at finding imaginary solutions to quadratics. Okay, we're going to find imaginary solutions to quadratics. Does anyone still need that up there? So we're going to go to example B. Oopsies. Okay, please don't do this, computer. Stop.
Guess the lesson's done for it.
Please, I'm almost there. Just let me. All right, there we go. All right. So 4x squared plus 11 equals 6. What do I do to get x squared by itself? So we're going to start by subtracting 11. So I get 4x squared equals, how do you get x squared by itself? So x squared equals negative 5 over 4. That's a negative 5. It glitched a little bit. That is negative 5 over 4. All right. So now to get rid of the square, I take the... Notice I do need to have that plus or minus. So I get negative 5/4. Negative 5/4. But that's a negative under the square root. So a negative under the square root, that's negative 1 times 5/4. So when I have that negative 1 under the square root, that's imaginary. When I have a negative under the square root, that's your imaginary unit. Anytime you have a negative under your square root, that's an imaginary unit. So I take this negative right here, I take this negative, and I bring it outside as the imaginary unit I. I is always outside the square root. I bring it in front of the square root. And that represents that imaginary unit of the square root of negative 1. And so under the square root, I'm left with 5 over 4. Oh, it's still glitching. All right, so that's I, square root of 5 over 4. I, square root of 5 over 4.
My book doesn't have I. Yeah, my book doesn't have I. His does now.
And we're missing a box.
Yeah.
Yeah, she's missing something too.
Fix it. If yours doesn't have it, fix it. Sorry, guys.
Oh, so I thought I was on the wrong.
Nobody last period said a word.
Mine has it.
So
does Chad's.
our books came from 2 different batches. So one group came from the fixed batch. The rest of you have last year's batch. Sorry. All right. So now I have I have plus or minus I, the square root of 5 over the square root of 4. What's the square root of 4? 2. So how I would usually write this is I'd write I square root of 5, and I put that all over 2. Because the square root of 4 is 2. And what's nice about this is fully rationalized. There's no square root in my denominator. Is this solution imaginary or real? Imaginary.
So you write I always next to the numerator, or can you just put it in front? Or does it have to
So you can write it like this, or you can write it as square root of 5 over 2 I. Both are correct. They're just different notations for the same thing. All right. So let's take a look at number 11, then I'll have you guys try number 12. Are number 11 and 12 the same problem by chance? Wait, no, like, do they match what I have on the projector? I should say. Okay, let me adjust that wording. All right. So good. At least we have the same problems. All right. So how do I get x squared by itself? So 1/4 x squared equals negative 9. How do I get x squared by itself? So x squared equals negative 36. How do I get x by itself? What goes in front of my square root? All right, so I have x equals plus or minus. I have a negative under my square root.
So what did you put, substitute for times?
So I'm going to put I in. So instead of that negative, I'll have I.
And then it would be square root of 36.
And what's the square root of 36?
So simple.
So 6i. Now, you could write that as, you could have done extra steps. So you could have written I square root of 36 and then made that I 6. And then usually we just write the coefficient in front of I. Just like you'd usually write like 6x, we would write 6i. Okay? And so there we go. There's my answer. So is this solution imaginary?
Yes.
Okay. And so what specifically is telling you imaginary? That base unit of I. That base unit of I tells us it's imaginary. If I has any exponent, then you need to simplify it. If I has any exponent, you need to simplify it. All right? Because different exponents of I will have different properties. All right. So let's look at 12. Well, you guys try 12.